Hello everyone, we will be analyzing a green hook defined in this problem using mechanical APDL. I'll use mechanical APDL product launcher instead of mechanical APDL as it will allow me to handle the files more effectively. I'll define a working directory as curd bean. The first part is the modeling. Modeling is done as this. We'll create an annulus of outer radius 40 and inner radius 20 mm. We'll also create a rectangle with the center of 0,20 plus 25, that is the inner radius plus half of the rectangle length, and the length is 50 mm, and we'll create two lines so that we can divide the entire area and delete the unwanted part. So preferences, structural analysis, preprocessor, element type. As this is a plane stress problem, we can always use a solid element of 8 node 183, a quadrilateral of 8 node, with an option for analysis of plane stress with thickness. Okay. Now I'll define the real constants for the material defined. The thickness is 6 mm. Defining the material properties, structural linear isotropic elastic material. Going to the modeling, I'll create area, a circle annulus with a center 0, 0 and a radius 40 and 20. Now rectangle by center. The center of the rectangle is 0, 45 and a width of 20 mm. 50 mm is arbitrary height that I have chosen. Now I will perform Boolean operations to add two areas. Here comes the part to delete the area, the unwanted area. I'll just plot the key points. So now we'll be creating key points in active CS at the origin, at 0 and 20, it's 10 and 20. Now we'll create lines using these key points. Okay, I'll go to multiplot. So here are our lines. Here is a line, and yeah. Now I'll again perform a Boolean operation to divide the area by line. I'll select the area. The lines are this many lines. Now the area has been divided, and I'll delete the unwanted area. Here we have two options, areas only and areas and below. The areas only will delete only the area, but the areas and below option will delete the area, the key points and the lines associated with it. Whatever the primitive features which comes below the area will be deleted. So going to multiplot, I'll create a line fillet at this corner and this corner. So creating a line fillet of radius 10 mm. Yes, again here with a radius of 10 mm. Here we have not created an area, we have just created a line. So whatever the empty space is there between the line fillet and the structure what we have already done, we should fill that area with an arbitrary area using lines. I'll use the fillet and the two adjacent lines. Okay, yes, I have filled the area. Now I'll add these areas using the Boolean operation. Add areas. Areas are added. I'll go to multiplots and we have another fillet, and this area which is not necessary is involved in this area. So I'll delete the area by dividing the area using a Boolean operator. Divide area by line, entire area, okay, using this line, and delete areas and below. So here is our final model. I'll save the database. And now coming to meshing. Mesh tool, I'll set the area, set the element edge length as 2 mm, and I'll mesh the area. The area has been meshed. Now applying the boundary conditions. I'll define a displacement on line to fix this. That's where all DOFs are constrained. And I'll apply a force at this point. Before applying that force, I'll also create a key point at that point, minus 20, 0. Sorry, that's 0, minus 20. The key point has been selected. So load on key points. I'll select this key point. There is a force of 1000 Newton in the negative y direction. After the boundary conditions, I'll solve this. Solve from current LS. Yes. While plotting the results, as the force applied is in y direction, we'll be interested in getting the stresses in the y component of stresses instead of the von Mises stress, where the y component stress gives the bending stress in this. We have been asked to obtain the maximum values of stresses at inner and outer fiber. At inner and outer fiber, so we need to obtain the minimum and the maximum stress, that is the maximum tensile stress and the maximum compressive stress. So to obtain that, we need a roadmap just to select the points. So I'll define a line. I'll create a line, a straight line at the center, so that I can obtain the results more accurately. just switch it to multi-plot. Now go to general post processor and we have query results. In query results we have subgrid solutions. This actually allows us to select a particular value at a particular node just by the click of the mouse. I'll plot lines, so I need a value like this. The inner fiber has been denoted 106.872 Newton per mm square. This is the compressive stress value. To draw the stress distribution, we also need any point at the center of the flange. So here I'll select. We can select as many nodal points we want. After this, we just need to plot the graphs and show the distribution along the flange thickness, and that will be our solution to the problem. Thank you.